Hello, this time we are going to take a look at question 111, minimum depths of binary tree. In this problem, we are given a binary tree. Our job is to find its minimum depths. So what is depths? Let's take this example. So in this example, we are given a tree like this. So what is its minimum depth? So we can see depth is counting from the root. So root is counted as 1, and then 2, and then this 15 and 7, which is 3. So because it tried to find the minimum depth, which is 9, because 9 is already a leaf. So look at the definition. The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Nearest leaf node, which is 9. So 3, 9, 1, 2. Okay, let's get into coding. So how are we going to get the minimum depth of a given tree? So first, we have to consider an exception, which is if not root. If the root doesn't exist, what will happen? The minimum depth will be 0 because the tree doesn't exist. So there's no depth. Okay, now we consider another condition, which is if root left exists and root right doesn't exist. So what we will do will be calling a recursive function of itself of the left side. So for example here, so when this 9, when this how do I say? So here, this is not a good example here. So let's make an example. For example, 3, 9, and 10, and 2, then it's finished. So for example, so it goes to here, then find out the left side exists, but the right side doesn't exist. So what it will do is it will call a recursive function on this side, and then this recursive function will keep going and find the minimum depth of it, find the depth of this node. So here we will call it on the left side, and if root right exists and root left side doesn't exist, what we will do, take a guess, we will call its right side. So after this, what's the condition left, which is the left side and right side both exist. So what we will do is, because we are trying to find the minimum depth, so we will find the depth of left side and right side plus 1. So why we know the left side and the right side will return the depths we want? It is because this recursive function has a base condition, which is if not root, we will return 0. So we will know, and so as the recursive function going, the value it returns will always keeps an increment 1, as it goes. So that's how we know this. Now let's check if we are right. It says wrong answer. Oh yeah, yes. So here we will have to return as well, I think, and return this +1, because just calling it doesn't do anything. If the case is like this, we have to return, and we also have to increment 1. So this should be right. Yes. So here, then this 3 condition and this base condition. So this 3 condition, I'll go through these 3 conditions one more time. So it is the first condition is the left side exists and the right side doesn't exist. So for example 6, 5, then this is known. So it will go through this and will +1, so we will get the depth of the left side. Yep. The second one is exactly the same, just the right side. And the third one is they both exist, so we will find the minimum one because we've tried to find the minimum depth. Yeah, so because we try and find the minimum depth and the one is smaller +1 and the one is bigger +1. For example, I'll make an example. So for example, A is less than B, then A +1 should be less than B +1, right? That's why we choose the smaller one, because we try and find the minimum depth.